you need to understand the business case very well
Yeah.
before you even go in and try to assess what is needed at that specific facility. So taking again the example maybe of plastics molding, well, if you have a problem with capacity, then you're probably looking at the discrete process. And so you're going to start there, but maybe you evolve in your materials that are going to be a little bit more continuous.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our #1 priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. Identifying the appropriate production method requires you to have a deep understanding of your finished products and raw materials consumed. An incorrect production method and its KPIs may have implications on the production capacity. Also, if there is a mismatch in your demand and supply, you might need to understand if there might be a way to increase the capacity. If you are lucky, you might be able to duplicate the existing line and increase it. But if you have to install a new line from scratch, there might be a lot more moving pieces and surprises than you would expect. In today's episode, our guest, Vlad Romanov, shares his insights into how the two schools of production, discrete and continuous, differ, including their KPIs. He also shares his insights into optimizing the production lines by analyzing the types of products produced and the types of raw materials consumed. Finally, he discusses how to increase capacity by analyzing the business case of installing a new production line versus upgrading the existing one. Let me introduce Vlad to you. Vlad is a manufacturing business professional with close to 10 years of experience across engineering, operations, and maintenance leadership roles at large. P&G and Kraft Heinz and small companies with formal education in electrical engineering and MBA. His project highlights include $20 million line installs, $4 million plant upgrades, and various cost savings projects. With that, let's get to the conversation. Hey, Vlad, welcome to the show.
Thank you so much for having me.
Of course, and I am so excited to have you. I have been waiting for a very long time to have Vlad on my show because number one, you are super popular and influential in the technical community. So the insight that you are going to bring for our listeners, it's going to be super fascinating. Just to kick things off, Vlad, do you want to start with your personal story and your current focus?
Sure. I can give you a background, I guess, of how my career progressed. So I graduated in 2013
Yeah.
as an electrical engineer from Concordia University up in Montreal, Canada, and immediately moved to the States. So I began my career. At first, I had some, I would say, fairly simple engineering jobs. And what really piqued my interest is an offer that I got from Procter and Gamble
Yeah.
out of Maine. So I immediately jumped into manufacturing. I learned quite a bit in at P&G. I was able to work on numerous projects, which we can discuss a little bit later, but I was extremely focused on the technical side. So I was, on the manufacturing floor, solving technical issues, installing new lines, meeting engineering KPIs, and great experience overall. From there, I moved to Kraft Heinz on the food and beverage side, where I learned a slightly different aspect of the business. So I was more on the maintenance side. So the challenges were slightly different. We needed to maintain the facility, but also be very conscious of the cost of the financials, because as you may know, there was a merger between Kraft Heinz. And again, we can get into a little bit more details of what that looked like. So learned a slightly different aspect of business. And from that point on, unfortunately, the plant I was working at closed down, but I had a really good connection with a systems integrator that worked out of that plant. So I started consulting for various plants across North America for this small systems integrator and worked on all sorts of projects for installing new plant upgrades
Yeah.
to figuring out data solutions. So they were trying to modernize some of their equipment. And ultimately, the question always was, where can we invest our money?
Yeah.
Right. And so data allowed them to figure out either critical areas to improve or maybe lines that needed to be fixed, augmented, increased capacity. So again, multiple projects across that area. And while I was doing that, I was trying to also figure out some of the business aspects for
Yeah.
myself. So I decided to go back to school, get my MBA, which I've completed a few months ago. And while doing that, I also tried to solve a different gap in the market. So as you know, there's a lot of opportunities when it comes to upskilling individuals in manufacturing.
Yeah.
And I think we're only going to see that need more and more. So what I mean by that is engineers need to be trained in manufacturing, technicians need to be trained in manufacturing. So I also have a small business on the side where I help manufacturers upskill their workers. And so here we are today, working on multiple areas. I have integration projects, I
Yeah.
have upskilling projects and data projects.
That's amazing. So it's going to be so fascinating to dig into some of those stories in terms of, what has been your learning, what's been success rate. Obviously, with any projects, there is going to be some challenges as well, right? So we would love to dig into what has been your lesson learned. But before we do that, we have one of the standard questions for all of our guests that come on our show. And that is going to be, Vlad, your perspective on business growth.
Yeah, that's a very interesting question. So business growth, again, I want to tie it back a little bit to my own experience, and how data allowed, specifically, I guess, Kraft Heinz, because that's where I was, but I think business in general. And so the opportunities that I see there is a lot of manufacturers currently have some kind of a system in place that will track, let's say, number of products made or number
Yeah.
of batches produced. But what more and more executives are, I think, understanding now is that data can give them a lot more leverage than that, right? So they're trying to understand, why are their lines not producing at the level that we want, right? So you have a certain OEE metric. The gold standard is 85%, which you probably know about, and everyone's trying to get there. But the challenge is that not everyone has the right tools to understand what is the path to get there, and ultimately how can we impact the bottom line of the business. And so I guess to answer the business growth question, data, I think, can answer a lot of those questions for you. How do we get to the next stage? How do we fix some of the quality issues that we're seeing? How do we fix the capacity issues that we're seeing? And so I think data is ultimately a very big factor in business growth in the next decade.
Yeah, so some very interesting insights there. So I'm actually going to follow up on one of the comment that you made, and I don't know how many manufacturers are going to be really familiar with this specific metric. Some manufacturers have really sophisticated manufacturing processes. Some are trying to sort of catch up. So let's say if they might not know what is the difference between number of products and number of batches, and some of the manufacturing executives, let's say if they never take a visit to the shop floor, they are probably not going to know about that. So describe to us, what is the number of product and why it matters, these metrics.
Yeah, so that's a very good question. And I think, to start off, maybe to explain or to make it a little bit simpler to understand,
Yeah.
you've got two schools of production, right? You've got the discrete metrics and then you've got the continuous metrics.
Okay.
So the discrete metrics is when you have a manufacturing process that makes, for example, a can line, right? It makes a certain number of bottles per minute.
Yeah.
Right. So you're counting the number of bottles and ultimately number of cases and number of pallets produced on that specific lines. Now, behind the scenes of that process, you're still creating the liquid, right? So you're creating a certain batch that's going to go into those bottles. And that process is going to be more continuous in nature. There's no way for you to measure. It's only by volume that you measure how much you've created of that liquid. And so I would say that in manufacturing, there's a blend of the two. Even if you go to, let's say, a food process where you're manufacturing something like sausages, as an example. So I spent a lot of time working at plants of that nature. You have a batching process that will create the meat and will be able to cook the process and everything. And then you got the discrete process where you're building the actual packaging, you're building cases, and ultimately building pallets. And so that's the main difference kind of between the two. And the reason why you should care is because your data is going to be very different, and you're going to get different information out of the two sides, right? So on the batch side, you're typically going to, like I said, measure by volume,
Yeah.
but you're going to run into issues. You have maybe losses, right? So
Yeah.
a certain amount of your ingredients is going to be wasted in the process. It's going to be cooked off. So you want to understand, let's say you're putting in 40,000 pounds into a single batch.
Yeah.
How much product are you actually getting out of that 40,000 pounds, right? So you're more understanding of the volume. Now, on the discrete side, it's more of an OEE metric where you're trying to understand, well, we're making a certain number of cases. How many cases are actually making it to the pallet? How many cases are being rejected for quality defects? And then how do they process through the different pieces of equipment, right? So in a typical, again, manufacturing packaging environment, you have, let's say, a filler, you have a capper, you have a case packer, you've got your palletizer. And so each machine is going to play a different role, but it's also going to have its own metrics on how it's performing that specific process. So hopefully that makes sense. Those are the two kind of big areas of manufacturing.
Yeah, so it does. And I'm actually going to build on top of that, provide you some more colors, based on what we have seen in the other industries. And then maybe you have some more, follow-ups to add there. So obviously you do a lot of work in the food space, food and beverage space. And in case of your food and beverage space, just because you have two different sort of the materials that are interacting with each other, one is going to be slightly more food centric, the way you define your continuous, and then one is going to be slightly more product or assembly centric, the
Yes.
way you describe your cans, right? So
Mm-hmm.
obviously the production is going to be very different. But I don't know how many manufacturers really understand the difference between these production types. And sometimes what they are going to do is they are going to produce your, let's say, if you're producing food products, just like the way your discrete production is going to be. And Vlad, you have lived this life for a very long time, and you can see so many different challenges just because you have so many different data sets and metrics that are going to be completely different, and it's probably not going to work if you actually do, let's say, if you are going to follow the discrete manufacturing methodology in your batch or continuous manufacturing process, then it's probably not going to work. Now, let's talk about some of the other industries, such as industrial manufacturers, right? In case of industrial manufacturers, they are not going to have these issues related to your continuous production because they are purely discrete shop. They don't have to measure anything related to volume. But there are some nuances, okay? For example, let's say if you go to plastics industry, they sort of have mixed as well. If you go to
Mm-hmm.
chemicals industry, they sort of have mixed as well. So what would you think of this? I mean, see, do you agree with my assessment? Do you have anything to add from the KPI perspective? Or what are going to be implications, let's say, if people don't understand how these production methods differ and if they try to mix those?
I think, what's important to realize is that we always want to tie it back to the business opportunities and
Yeah,
business cases that you see in these different areas of manufacturing, right? So I would say that taking a step back, the methodologies are certainly going to vary, and there's going to be different levels, as you mentioned, of discrete versus continuous. But I think the challenges and the way that you can apply data to solve those challenges are going to fundamentally remain the same, so to speak. But I think, again, you need to understand the business case very well
yeah,
before you even go in and try to assess what is needed at that specific facility. So taking again the example maybe of plastics molding, well, if you have a problem with capacity, then you're probably looking at the discrete process. And so you're going to start there, but maybe you evolve in your materials that are going to be a little bit more continuous. So I wouldn't necessarily say that it's a one size fits all answer. It needs to fit the customer, and it
yeah,
needs to address a specific business case. And I mean, I can, maybe give a better example that would illustrate it from my experience. So one of the meat facilities for, again, I'll mention the company Kraft Heinz,
Yeah.
had a problem where they would continuously lose a lot of their batches due to quality control and just system rejects, right? And
Yeah.
so they didn't fully have the answer as to why. So again, taking back as to what I had said, they would put in 40,000 pounds of meat, and then at the end they would get 20 pounds, right? Like of actual like sausages.
Yeah.
So imagine really big
Yeah.
sausages coming out of the line that are then produced into cold cuts. And so the application was understanding why is that batch not translated to the same weight, right? And so obviously, if you want to tie this back to financials, they're losing a lot of money because they're putting in
Yeah.
all these raw materials, they're not getting the final product. And so by applying data into that process and tracking all of the technical components that go into producing that batch, you're able to see, well, at this time, the batch is doing this. Your tank is mixing, then your tank is cooking, then your tank is, let's say, sending it to a different process where the meat is, staying for 3 hours. Then certain other ingredients are being added. It's mixed again. And so you're able to step by step see how the batch is being processed and realize, well, like at this step, for example, the operator made this one mistake that caused the batch to lose a certain quality level and thus get rejected at the next process. And so again, by realizing that, you can address the deficiency and you can save a lot of money on the business bottom line by looking at the data. Hopefully that answers.
It did, and I'm
Right.
actually going to build some more on top of
Okay.
that. So let's say if we are talking about building the business case, right? So we are actually going to look at the business case. So let's say if I'm the executive and I don't really understand the nuances of the production process, to be honest.
Mm-hmm.
Somebody told me that I'm probably discrete and I'm discrete today. That's how I started. I developed my processes. Things have been working, but I don't necessarily know if I have a way to improvise my processes, right? Now,
Mm-hmm.
let's say if you were to sort of analyze from the top floor that okay, this is the business that I'm looking at, and I need to find out if there have been slightly more mixing of the production processes. And as we both can agree right now that if you mix the production methods, then there are going to be some issues. So let's say if you were going to analyze a business, what would be your first approach in terms of analyzing whether a specific production line should be more of the continuous or should it be discrete? So are you going to look at the materials? Are you going to look at the products? Are you going to look at the equipments? So how are you going to analyze which should be the right fit for discrete, which are going to be right fit for continuous?
Yeah, good question. So I think to start off, I would definitely understand our product better, right? So if
Okay.
I was a top level executive, I would start looking at what are we actually like producing at the end of the line, right? So
Yeah.
again, could be very continuous, could be very discrete, and then I would start asking questions around. So one of the most common metrics that I would see in manufacturing is what is our cost and profit per case,
Yeah.
right? So you would start looking and understanding the financials around that. And you can start giving questions to, let's say, a plant manager at that point in time and be able to gather information that he collects from his either supervisors or the plant floor. There's usually a way to collect that information. What are we getting in terms of costs on a case basis? And if it's a continuous process, then obviously it's on a batch but volume basis.
Yeah.
And at that point, you can start optimizing those metrics, right? So you can start asking questions where are we losing the most money, right? So on that one case, there's going to be typically, again, the list can be very long, right? Like
Yeah.
it could be we have rejects, we have rework, we have additional personnel that needs to come in to, so it could be an array of different things. But I think the step there to improvement is figuring out the top three and start addressing them with your team, right? Start asking the right questions. Why are we losing money on this? Why can we not improve like item number 2? So that's kind of like where the delimitation goes. And again, I think to come back to your original question, that's where you can again have that discussion. Are we losing more dollars on the discrete part of our business, or is it more in the continuous process where we are losing, let's say, raw materials during the cook process, the mixing process, and so on?
Okay, so very interesting insights there, and obviously we can look at all of that. But one of the things that you have been using a lot, and that is going to be really the volume keyword that you used a lot overall in this conversation. So can I draw the conclusion that if something is going to feel more like liquid or food, that is probably going to be continuous, but the other things that are going to be not as volume centric, if they can be measured in, let's say, in other unit of measure, then they should probably be screened. But I'm pretty sure there are going to be some gray areas in terms of identifying whether discrete is going to be the right fit for that specific product, or the continuous is going to be the right fit. So what are your
There's
thoughts?
there's always gray areas, right? Like as you said, I think when you transition from continuous to discrete, there's always a very fine line, and
Yeah.
it's usually I would say a technical challenge more than anything else to be able to tie in the two kind of transitions together in a competent, I would say, OE or MES system that would very well represent that continuation. And to be quite frank with you, I haven't seen it implemented to like 100%. There's always this maybe strange phase in between where you almost put an end to your batch, right?
Yeah.
So you finished your batch, and then your discrete system is almost like a standalone system that works with those discrete products that are a result of that batch.
So very interesting. So one of the comment that you made towards the beginning of the episode, that you are also involved in installing a lot of different new lines. And
Mhm.
obviously there's going to be a process to build the business case. There is going to be a process to analyze, okay, what is the problem with the existing line before a
Mhm.
CFO is actually going to cut you a check of $1 million to install the new line.
Yep.
So describe the process in terms of, what is that process? I mean, what are the factors that we are looking at? And if you have a story where you have done this yourself, right, going through the whole process of what are the things that you should be looking at in figuring out whether it makes sense to install a new line, or should you be upgrading some of the existing, either the process or the equipments.
Yeah, so the conversation usually starts around the topic of increasing capacity, right?
Yeah.
So either the demand is so high that we're not able to meet it with the current lines that we have. And so again, maybe to paint a better picture, we had 15 lines at the facility at the time where I was working at P&G.
Yeah.
And so the question was, how do we increase capacity? So there's really two ways to proceed. Either we speed up or increase the capacity of existing lines, or we pay for an additional line, right? Like at that point in time. And so the two questions need to be evaluated side by side from a financial standpoint in order to understand which path is the better way to go. And I would tell you again, I was never involved on the sales side,
Yeah.
so
Yeah.
they just brought the question to us to understand what would make more sense. And so the two projects would be evaluated again. If you want to speed up a line, that's quite a process, right? So
Yeah.
going from on a 20% increase of capacity on a single line is a very complex, I would say, technical challenge. So what that really takes is involving engineers both on the electrical, mechanical, and process sides in order to figure out, well, which components are we going to have to upgrade in order to make sure that we can sustain the same OEE or efficiency at a higher speed, right? Because the nuance I think is not often understood is that on the electrical side, at least, I can increase the capacity, I can increase the speed of the line with the push of a button, right? It's
Yeah.
just an increase of 20%. The problem is that you're going to get a lot more failures when you do so without changing any other equipment. So you need to really understand what's the cost of buying that additional equipment, what other failures are we going to get at higher speeds, and what is it going to take from the process standpoint, right? So your transformation is happening quicker, therefore there might be, I would say, unaccounted for adverse effects, right? And then on the other hand side, like I was saying, we can buy a line that we can just put next to the existing lines, and the challenges there are much more straightforward, right? So the risk is reduced because you already have, in my case, we already had 15 lines.
Yeah.
So you can just copy the equipment that you've already deployed and deploy another line. Now, the challenges, like I keep saying, could be building. So what is required on the building side? Do we need to expand the building? Do we need to build additional electrical infrastructure, right? So these are very, I would say, energy requiring lines. So perhaps we need to upgrade the MCC. So there's investments there. There's the cost of the line itself. There's the cost again of the cooling of the line, just staffing. So there's a lot of details, but there's a lot less risk, right? So I want to emphasize that point that there's two options. One that brings a lot more value, I think, because it will increase the capacity of each line at the facility. And then the lesser risk one is just we buy another line. Now, from a practical standpoint, like I said, in both cases, engineers go and evaluate what it's going to take from a technical standpoint. There's going to be a bill of materials. There's going to be a project timeline so we can get either one done, let's say in 6 months.
Yeah.
And then you would submit that back to your engineering managers who would then have a conversation with the VP of Finance, the CFO, and then propose the two options, and somebody would make a call which way we're going to proceed.
Okay, so here obviously there are a lot of moving parts, and this is going to be a fairly involved process. And let's say if the CFO or the finance executives are making the decisions, they need to know a little bit more, right? Because obviously they have to find out whether the option one is going to be the right fit or option two is going to be the right fit. And then the other comment that you made is that, you know what, if I have 15 lines that are working properly, and if I buy the exact same equipment and I duplicate the same line, then you are probably going to be increase the capacity, and you are not going to have any surprises. But in my experience, when you work with any of these systems, I can almost guarantee that you are going to have some surprises, even if you are simply hitting the duplicate button there. Which is not going to be as easy. Obviously, you have to extend the facility, you have to install the electrical infrastructure, you have to install these equipments. So what are some of the best practices overall you have seen? Let's talk about first, let's say, installing the new line. Are you always able to get the same performance, or can I expect any surprises in installing the new line?
There's always surprises. I think they're different in nature. Taking it back maybe to the executive level, I think they don't necessarily are concerned with some of those surprises, because at the end of the day, they know that the technical team will deliver the capacity that is required, right? There's going to be for sure fluctuations in the budget, but there's always buffers to account for any differences, any maybe installation delays. And, from a practical sense, let's just kind of maybe walk you through the process of what my experience was installing a new line, right? Because I went through that at P&G. So as I was saying, the first step once the project is approved is to make sure that you reach out to the vendors of those equipments and get an accurate, very good quote from them, like when can it be finalized, and make sure that you get the entire scope of work for when those deliverables are going to be met, right? So while that's happening, you also have people on the building side who are assessing, well, are we able to put this line right here? How many people is it going to require to operate? What kind of electrical upgrades are we going to do? So there's going to be some scheduling involved on that side as well. Once the different components of that line are complete, so I actually had the opportunity to go and travel and do what's called FATs, so factory acceptance tests.
Yeah.
And that's a very important step. I'm just going to give a little bit more detail as to what that looks like, because once the equipment is assembled and is ready to be brought into the facility, there is the step where engineers or technical personnel are going to go in the field and actually test that the equipment meets the needs that were specified by the company, right? And so you make sure that you get the right reliability before you sign off on the equipment to be shipped to your facility. And then once the equipment is all at the facility, it's essentially the beginning of a long, I would say 3-month long process in my experience of actual construction, deploying this equipment onto the floor. There's obviously a lot of moving components, a lot of different people. So I was on the electrical side. You also have mechanical engineers, you have process engineers, you have managers, and whoever else that's responsible for this. But you need to orchestrate, for example, your electricians need to come in and start wiring in your equipment. The mechanical folks need to make sure that everything connects well. They do their own tests. The process engineers would typically take care of the quality. And so, to answer your original question, there's going to be snags along the way. I think it's to be expected, right? And it could range from, let's say there's a missing component, right, that is no longer being made by the manufacturer that it was made for the previous line that we've installed. So now you have to figure out this engineering challenge. Well, what can we replace that with? And ultimately, as I was saying, in the span of those 3 months, you are, I would say, required or have confirmed that you can bring that line up to the same metrics that have been established by the site, right? So through those snags, you work and you figure out a way to get it to where the other line is, because you have a base condition of where the same line is operating at metrics.
So very interesting. So let's say if I actually were to ask you, what are the major variables that really drive the OEE on a line? Okay. So let's say you have a line and you are thinking that, I'm simply going to duplicate. Obviously, there are going to be surprises that, some components may not be available. But let's say if you look at the major driver that really drive the OEE, is it going to be the electrical side of the house? Is it going to be mechanical side of the house? Is it going to be process? Is it going to be tooling? Is it going to be configuration? Is it going to be equipment? So tell us, what are the major variables that really drive the real OEE?
Yeah, of course. And to come back to that like specific example, I may be illustrating a very streamlined process. I'm obviously taking a few shortcuts, but it's important to realize once the line is actually turned on and is making the first product, the typical reliability, again, from my experience, is around 20%.
Okay.
Right? And so there's a very long way to get to that 85%. And the challenges are multiple fold, right? But I would say from what I've seen, like on the discrete side, it was a lot more focused on mechanical adjustments, right? Because electrically speaking, it's easier to understand how the system is running, and it's I would say easier to pre-program the line the same way as the previous one was, but you work together as I would say, a multidisciplinary team, because you provide the tools to your mechanical engineers to be able to solve certain problems. And I'll give you, I guess, a very common thing in startups of that nature is starting up servo drives. So this is a line with over 100 different servo drives. So when it comes to the mechanical components, the mechanical engineers, can tie in your gears, your pulleys, your belts, and they understand how that works.
Yeah.
But as the electrical side, you are able to give them, again, data and statistics and analysis of how those drives are performing so that they can make adjustments on their side. So it's really, I would say, a problem that involves both disciplines, but a lot of it rests because you're making a physical product on the mechanical guys. And maybe, to come back to also bring some other items back to the table, like scheduling and making sure that things are done in the order that they need to be done is very critical, right? So as I've said, there's many moving components. You have construction crews that are coming in for different areas of your line. And so if there's any delay in that schedule, it's going to, I would say, ripple through the entire project. And what I mean by that is, let's say your electrical contractor is behind by 2 days. Well, your mechanical engineers and your process engineers cannot go into the equipment to do the tests that they need, right? So I've seen a lot of delays just on like the operational side, and vice versa, right? If the mechanical engineers are taking a little bit longer to validate certain components of the line, well, that's going to push back your electrical crew by days or weeks sometimes. So like orchestrating, and I would say just general good project management practices are very important in like those tight deadlines.
Yeah. So basically, when you are working on all of this, you need to work with a lot of different vendors. You mentioned that, you need to actually get the codes from them for different components. You are going to make at least million assumptions. And you also mentioned that the reliability is very important. So I am pretty sure that, when you work with these vendors, I don't know how many surprises you typically get when you are, let's say, acquiring either components or the equipments. There are going to be some surprises right there. And there are also going to be red flags, in my opinion, because, yes, sure, there are going to be very competitive salespeople, but there are going to be, salespeople who are not going to be as competitive, and they might be overselling mistakenly or whatever. So what are some of the surprises that you have seen when you are working with these, let's say, hardware vendors and acquiring these components? Because if you actually acquire a component with the incorrect specification, then your model falls apart because, it's not going to work. So what are some of the red flags that you have seen from the hardware component perspective?
That's a really good question. I really like that one. So the first thing that I will mention is like relationships are super important with your vendors, because these are people you're going to work with for, like I said, first of all, several months to make sure that everything's working.
Yeah.
But you're also building something that hopefully you're not just buying a single piece of component, right? Like you're buying this every almost again, like that plant was buying it every year and trying to increase capacity year over year. But the challenges are, I would say, when things change, right? So those hardware builders usually buy third-party components that will be installed on that piece of machinery. Now, if you have a very good relationship with that manufacturer, they're going to explicitly tell you, again, drawing this back on my experience, they will explicitly tell you, well, this component is no longer available. We're going to build something different. Here are your options, Vlad. You can either choose like this component and it's going to change your, let's say, programming in this way, or you can change this component and it's going to impact you in a different way. There's going to be obviously some engineering costs associated with integrating that. Now, the biggest challenge is when the vendor doesn't tell you about those changes and they take the liberty, I would say, to make those changes. And then once you get to, like I was telling you, to the test, the VAT,
Yeah.
you're going to find that out the hard way. And so again, if you get there and they've replaced the component with something newer without really telling you and knowing what that's going to do to the system,
Yeah.
you're getting into, first of all, losing hours trying to figure out what's going on, but then you're also going to have to figure out that solution on your own, right? So I would say like that's the number one like red flag when things have been changed and are not done to spec that was agreed upon when you were buying that piece of hardware. So communication is like very important, and I think the learning point for me is that different cultures have different ways of communicating things,
Yeah.
and sometimes you need to learn how to draw that information out, and you need to ask the right questions in order to get those, as you said, like red flags,
Yeah.
and bring them back and understand what's going on. But yeah, I would say like honestly, like that has been like the biggest challenge, and I think that's why again those FATs that are I call them sometimes FATs or VATs, so it's factory acceptance test or
Yeah.
vendor acceptance test, depending on which side it's done. But ultimately, if you have a good communication and a good understanding, those VATs go very smoothly. If you don't, then you fall into a lot of problems where, like I said, you uncover in the field, and then you have to go through the process of telling your vendor to find the right solution and do what's right for the system before you ship it over.
Okay, amazing. So that's it for today, Vlad. Do you have any last minute closing thoughts or remarks for our listeners?
No, I really appreciate the discussion, Sam. I think the number one lesson I want to take maybe a step to the side of what we discussed, but I want to say that very important for especially executive leaders, I think, in today's marketplace to learn not only I would say the high level about the technologies that are being in manufacturing, but I think to try and get a better understanding on the technical side of what those technologies can bring to the business. I think that there's a lot of really good information available about AI, machine learning, SCADA systems, MES, OE, but I think it's important to have a deeper level understanding in order to be able to understand how it brings value to your organization.
I completely agree. In fact, I mean, my personal takeaway from this conversation is going to be any project that you implement, whether it is going to be software, hardware, or related to production operations, they are all going to have very many moving parts.
Absolutely.
But they are also going to have a lot of value if done right. So research a lot, understand how things work, speak to the experts like Vlad, and then implement it. On that note, Vlad, I really want to thank you for your time. This has been a super powerful episode.
Thank you very much, Sam. Thank you for having me.
Of course. I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Vlad, head over to solisplc.com. It's SOLISPLC.com. Vlad is currently working with manufacturers to upskill their personnel and aid them in their digital transformation journey. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Michael Peitel, who shares how he can create a far more precise digital twin of the warehouse by mapping warehouse workers in the system. Also, the interview with Kevin Paramore, who discusses the nuances of robotic automation of warehouse and manufacturing processes. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS podcast.
Thank you for listening to another episode of the WBS podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.